We are reviewing for our Trig chapter test, and we are going to start with a verification. Remember, we have a left side and a right side, and you just need to make a plan and then work the plan. So the first thing I'm going to do is I am not going to touch the left side because it does appear to be the simpler side. I'm going to work on the right hand side, and the first thing I'm going to do is replace my cosecant with 1 over sine alpha and my cotangent with cosine over sine alpha. So we do have a common denominator, which works out nicely. So that is 1 minus cosine alpha over sine alpha. So from here, about to forget that we have to square it. So what do we get when we square it? We end up with 1 minus cosine alpha squared, in which, because I want 1 minus cosine alpha, I am not going to multiply it out. Remember, always look at where you are and where you're trying to go. Now to the bottom, we do get sine squared alpha. And when we see sine squared alpha, we can make a substitution here and get on the top 1 minus cosine alpha quantity squared over 1 minus cosine squared alpha, which is factorable. And when we factor it, we get 1 minus cosine alpha times 1 plus cosine alpha. 1 power of 1 minus cosine alpha will cancel, and we end up with the left-hand side of 1 minus cosine over 1 plus cosine, and we're done. That's verifying. Another one to verify here, and obviously don't touch the right-hand side. So let's work on the left-hand side, and the first thing I see is that I can make a substitution right there and get something to cancel. 1 minus 1 plus cosine over 1 minus cosine all over 1 plus cosine. So that quantity cancels, and I'm left with 1 minus cosine x. Distribute the 1 or the negative 1, and we get 1 minus 1 plus cosine x, and that is cosine x, and we're done. So that's another verify. Next, we have some given information. We're given that the sine of theta is negative 2/5, and not theta but alpha, and alpha is in quadrant 3. We're also given that cosine of beta is 1/2, and that beta is in quadrant 4. So the first thing I'm going to do, and I think I'll just do this on a card to save room on the paper here, is let's draw these two diagrams. So first of all, quadrant 3, remember altitudes are drawn north and south to the x-axis. So there's alpha, there's negative 2, there's 5. 5 squared is 25, 2 squared is 4, 25 minus the 4 leaves root 21, and it will be negative because we are in quadrant 3. Beta is in quadrant 4. Beta is cosine adjacent over hypotenuse. 2 squared is 4, 1 squared is 1, 4 minus 1 leaves 3, negative root 3 is my missing side. So quadrant 4. Now keep these diagrams handy because we're going to use them as we expand these particular formulas. So first of all, this is the sign of a sum. The sign of a sum is going to be sine alpha, cosine beta, plus cosine alpha, sine beta. So from there, we are going to make our substitutions and then simplify. So we will get the sine of alpha. Sine of alpha is negative 2/5, and the cosine of beta. The cosine of beta is 1/2. The cosine of alpha is negative root 21 over 5, and the sine of beta is negative root 3 over 2. So everything's going to be over our common denominator, 10, and that is going to be negative 2 plus root 63. Root 63 comes from 21 times 3, and that, of course, it can be simplified. So negative 2 plus 3 root 7 all over 10. So this is the sign of your sum. We're moving on to the cosine of a difference, still using the same diagrams here. Cosine of a difference is cosine alpha, cosine beta, plus sine alpha, sine beta. Just a reminder that sum formulas, difference formulas, double angles, and half angles you are responsible for. So double angles, half angles I will give you. So now I'm going to make my substitutions here. Cosine alpha, cosine alpha. Cosine alpha is negative root 21 over 5. Cosine beta is 1/2. Sine alpha, negative 2/5. Sine beta, negative root 3 over 2. Once again, we've got a common denominator of 10. That is negative root 21 plus 2 root 3. And that is the cosine of your difference. The last one on this particular page is the tangent of the double angle. And the tangent of the double angle is 2 tan alpha over 1 minus tan squared alpha. So 2 tan alpha over 1 minus tan squared. So we're just making a substitution here. Go to the alpha triangle. The tangent of alpha is opposite over adjacent in quadrant 3. That will be positive. Remember, rationalize at the end, not in the middle of the problem. And then, of course, 1 minus tan squared alpha, so 2 over root 21 squared. So when I simplify here, I end up with 4 over root 21 over 1 minus 4 over 21. When I square 2, I get 4. Root 21 squared is 21. So let's change this 1 to be 21 over 21. So now I have 4 over root 21 all over 21 minus 4, 17 over 21. The next thing I'm going to do is now's the time to finally rationalize that denominator. And all we have to do is focus on just the numerator here and multiply by root 21 over root 21. So this takes us to 4 root 21 over 21 divided by 17 over 21. Division by a fraction will turn into multiplication by the reciprocal. So 4 root 21 over 21 times 21 over 17. Cancel, cancel. We get a simplified answer, which I will squeeze right down here, of 4 root 21 all over 17 for the rationalized answer of the tangent of the double angle. Next, we've got a couple of equations to solve. Firstly, this is the sign of 3x equals 1. We did these in class by using substitution, so I will let q equal to 3x. So that means we have the sign of q equals 1. So think about your unit circle, and where does the sign equal 1? The sign equals 1 right up at the top at pi over 2. So that means q equals pi over 2 plus 2 pi n. This is the only time where sign equals 1. So we're not solving for q. We're solving for x. So we're going to replace the q with 3x. So 3x equals pi over 2 plus 2 pi n. Next, we will be dividing by 3. So we get x equals pi over 6 plus 2 pi thirds times n. There is only one general solution here because there's only one solution for q. One, that's it. So this is the first thing you solve for, the general solutions. Now we are going to let n equal 0. When n equals 0, x equals pi over 6 plus 0. Let n equal 1, and we get x equals pi over 6 plus 2/3 pi times 1, so that is 2/3 pi, which we need a common denominator, which will be 6, so times 2, we end up with pi over 6 plus 4 pi over 6, which is 5 pi over 6. First answer, second answer. Now let's let n equal 2. So x equals pi over 6 plus 2 pi over 3 times 2. So that is going to be x equals pi over 6 plus 4 pi over 3. Once again, times 2 times 2. So that is pi over 6 plus 8 pi over 6. That is 9 pi over 6, also known as 3 pi over 2. Next, if we then say n equals 3, we get x equals pi over 6 plus 2 pi over 3 times 3. In this case, the 3's cancel, and we add 2 pi. And pi over 6 plus 2 pi is bigger than 2 pi, so we will be scratching that solution. So our solution set contains, first of all, once again, the general solution. This is the general solution, and then we have 1, 2, 3 specific solutions. I'll put them in a solution set. That is pi over 6 plus 5 pi over 6 and 3 pi over 2. General solutions and specific solutions. Next, and this is our last problem in the video, we've got the cosine of 2x minus sine x equals 1. So when we have an equation and it has two different trigonometric functions, it's best to try to make a substitution and then factor. So is it possible for us to rewrite cosine of 2x in terms of the other function that's known, sine x? Yes, it is. I'm going to do a direct substitution. Cosine of 2x is 1 minus 2 sine squared. Whoop, not x, not theta, but x. There we go. So minus sine x equals 1. So right now as it stands, take a look, even though it's poorly written, this is a quadratic. And if we have a quadratic, we need to put it in descending order, set equal to 0. So here we go. We've got negative 2 sine squared x minus sine x. And then, of course, a positive 1 on the right, positive 1 on the right and the left. Those just cancel. So there we are. We have set it equal to 0, combine like terms, and it's in descending order. From here, let's factor. The greatest common factor is negative sine x that we're taking out. So when we take out negative sine x, we are going to be left with 2 sine x plus 1. So we're completely factored. Set each factor equal to 0. So negative sine x equals 0. Divide by negative 1, we get sine x equals 0. If 2 sine x plus 1 equals 0, then sine x equals negative 1/2. So two factors yield two different general solutions. So first of all, where does the sine equal 0? The sine equals 0 right here at 0 and also on the other side of the pole at pi. So that means x equals pi plus pi times n. So, or we could just say, how about just pi times n, because that's a bit redundant there. So on the other side, where does the sign equal negative half? So first of all, where's the sign negative? The sign is negative only in quadrants 3 and 4, everything below the x-axis. The sign is negative half here and there. So that is going to be 7 pi over 6 and 11 pi over 6. Please be reminded that they are not on opposite ends of the same pole, so we do need two general solutions here. So x equals 7 pi over 6 plus 2 pi n, and also 11 pi over 6 plus 2 pi n. So check it out. 1, 2, 3 general solutions that will generate every possible solution, and then our specific solution set is just going to be 0, pi, 7 pi over 6, and 11 pi over 6. So 1, 2, 3, 4.